Hi, I am Basanta Pathak, a medical student and statistician. Welcome to Handy Research. In Handy Research, we are launching a practical guide to research series, a structured journey where we build research thinking from the very foundation. From epidemiology concepts, causal reasoning, study design, statistical analysis, and evidence synthesis. This series will help you understanding research step by step. This is not just theory, this is structured practical research education. And in today's episode, we are going to explore adjustment, how we control confounding at the design stage and at the analysis stage. Let's begin. In episode 4, we learned that confounding distorts association. And in episode 5, we learned that how directed acyclic graph help us to see structure. Now today we answer a very important questions. So once we identify a confounder, what do we actually do about it? So why adjustment matters? How do we control confounding in real research? Because the identifying bias is not enough. We must control it properly, and this is where many researchers make mistakes. They adjust blindly, and blind adjustment creates bias. They trust the regression without thinking. They include every variable in the model. This is not adjustment. This is statistical reflex. And adjustment must follow the causal logic. Today we will understand adjustment clearly, deeply, and correctly. So, why adjustment exists? Let us begin with a fundamental concept. In observational research, exposed and unexposed groups are not exchangeable. So, what do you mean by exchangeability? If exposure were randomly assigned, both groups would have similar outcome risks except for the exposure itself. But in real world data, this is rarely true. For example, suppose we study the association between exercise and heart disease. People who exercise often, they are basically younger, more health conscious, better educated, and less likely to smoke. These characteristics affect health risks. So if we compare exercisers and non-exercisers, we are not isolating the effect of exercise, we are comparing two different populations, and that is confounding. So adjustment exists to store comparability. Adjustment tries to answer what would happen if both groups were identical except for exposure. And that's the goal, and that's the goal of the adjustment. So how do we do the adjustment? There are two stages, that is the design stage and another is the analytical stage. So design stage methods control confounding before data collection, and analytical stage method control the confounding after the data collection. And we know prevention is stronger than the correction always. So there are three major design stage strategies: randomization, restriction, and the matching. And let us go one by one. So how do we randomize? Randomize is the gold standard, and in randomized controlled trial, participants are assigned to exposure groups purely by chance. Because assignment is random, confounders both measured and unmeasured and are balanced between the groups on average. Let's take an example. So if we randomize 1000 patients to drug A and placebo, so in that situation, age, sex, and different comorbidities all tend to distribute equally between groups, because what we did, that we did randomization. That is why randomized trials are powerful for the causal inference. And randomization break the link between the confounder and the exposure. So in many studies, especially observational ones, randomization is not possible. That's why randomization has some limitations as well. It may be unethical, it may be expensive, and it may be impractical, and it may not reflect the real world populations. That is the limited generalizability. That is why we need other methods. So what are the other methods? That is the restriction and matching. So let's go through the restriction. What is restriction? Restriction means limiting the study population to one level of the confounder. For example, if smoking is the confounder, you restrict your study to non-smoker only. And non-smoking cannot confound the association because it doesn't vary. So this is simple and powerful. It is simple as well as powerful. But there are disadvantages as well, because by doing that you reduces the generalizability, and you cannot study the effect of the restricted variable, and you reduces the sample size as well. So it is effective but limited as well. So what's the another option? That is the matching. What is matching? Do you know matching is very commonly is used in case control studies? So let's take an example. Suppose we are doing the study on smoking and the lung cancer, and we know that in smoking and the lung cancer, what would be the possible confounding factor? We know age is a confounder. So if lung cancer cases, and so how do we solve that issue? Through matching. We solve that issue like if lung cancer cases are older than controls, age will disturb the association. So we match while we taking the case 60-year-old, we select the control of 60-year-old people. Now age distribution is equal, and we solve the confounding factors. So there are two main types of matching, that is the individual matching and the frequency matching. Individual matching pairs each case with a specific control, pair each case with specific control, while frequency matching ensures overall group distribution is similar. Overall group distribution is similar. So what's the important point here? Matching balances the distribution of confounder, but matching alone does not remove confounding. You must account for matching during analysis. For example, a conditional logistic regression. Do you know matching could be dangerous as well? So what would be the possible condition where matching could be dangerous? Like if you match mediator, collider, then it introduces the bias, and that's why matching always must follow the causal reasoning. For example, if you do the research on obesity and the stroke relation, and obesity always generates the hypertension, and hypertension can cause the stroke. So if you match the hypertension, then you can possibly generate the bias. That's why we never do the matching on collider and a mediator. I have already explained the collider in the previous episode. Now part 3, that is the analysis stage methods. So when design stage control is not enough, we use analytical stage adjustment. This happens after data collection. So what are the methods in analytical stage? That is stratification, multiple regression, and propensity score. What is stratification? Stratification means dividing data into subgroups based on confounder level. It compares the crude versus stratified estimates and control one confounder at a time. So let's understand through the example. Let's suppose smoking causes the lung cancer. This is our own study. and we stratify the age less than 50 in one group and age greater than 50, and calculate the association separately in each age group. If the crude association differs from the age stratified association, confounding exists. It means that if the odds ratio 1 is equals to or tends to equal to odds ratio 2, then there is no effect modification, means age doesn't cause distortment. But if odds ratio does not equals to odds ratio 2, then there is effect modification present, that is there is distortion. That method is Mansell Hensel method. It allows to combine stratified data or stratified results. So what is its limitation? So it could be limited in multiple confounders. Let's suppose if there is the many or multiple confounder, then stratification it becomes impractical. It is only suitable for the one confounder at the time, so that we can stratify the data and calculate the odds ratio or calculate the association. Another one is the multivariable regression. So it can be done by adjusting the multiple confounders. Regression is the most commonly used adjustment methods. Let's take an examples. Same that smoking causes the lungs cancer. But in this condition, we take the age and socio-economic status as a confounder. Exposure is our smoking, and the outcome will be lung cancer. And the exposure depends on main variable. It is the main variable of interest. Age and socioeconomic status are the confounders, and the regression estimates that the association between exposure and the outcome holding the age and socioeconomic structure or status constant. It means that it hold the confounders constant and measure the association of exposure. That's why it is also known as multivariate regression, while stratification only does for one confounder. However, regression only adjusts for the measured confounder. If a let's suppose if a confounder is not measured, then it cannot be adjusted. So, regression and also relies on model assumption. I will write something here like it only relies on model assumption. So it means wrong model, wrong adjustment. Regression does not create causality, and it estimates the conditional association. So let's go through the another methods, that is the propensity score methods. So what is propensity score methods? It is the probability. It is the probability of receiving exposure given observed covariates. First compare it with regression and randomization. Propensity. Regression adjusts outcome models and the propensity balance the exposure models. Different method, but it has the same goal. But it also mimics the randomization, because the randomization balance the confounder and propensity balance the measure confounder. Let's go through the propensity now. So why propensity scores? Observation exposure is not random. Groups differ systematically. Regression may become unstable and need balancing approach. That's why we use the propensity score. And what is the propensity score? It is the probability of receiving exposure with given observed covariates. It can be estimated with the logistic regression. It summarizes the multiple confounders into one score, and it balances covariates between exposed and unexposed groups used in observational studies to reduce the confounding. Let's go through step by step. How do we calculate the propensity score? At first, we select the model exposure, like it could be the age, sex, severity, comorbidities, and it can predict the probability of the treatment. So now we estimate the probability of for each variable or for each exposure, like probability exposure or probability value for age, probability value for sex, severity, and the comorbidities. And we calculate the propensity score. Let's suppose if there is a patient A and he has propensity score 0.85, there is a patient B which has a propensity score 0.2, and patient C 0.6. Now what we do in the next step, we use that score, match the similar score, stratify the score, weight observation. It means that we select the patients having propensity score in exposure 0.8 in the cases, and another person which have the propensity score 0.8, like calculating through the variable different exposure, and take it in the control group. That's how we minimize the distortment and adjustment. So the goal is balance the measure covariates. We measure the covariable and balance it. So first covariates predicts exposure, estimate probability, and the balance the groups. That's the logic behind propensity scores. So what are the limitations of the propensity scores? We cannot control unmeasured confounding. Like if we didn't measure confounding factors or exposure, then we cannot calculate its propensity scores, and we cannot control unmeasured confounding. So it depends on the correct model, and it requires the large sample size. So now the critical warnings. What are the critical warnings? So do not adjust mediator, never ever, because I have already given the example above: obesity, hypertension, and stroke, and if estimate the total effect, do not adjust for the mediators. Do not adjust this, never. Do not adjust colliders. Let's take an example, like smoking also causes the hospitalization, and the lung disease also causes the hospitalization. Smoking and lung disease both send the people to the hospital. If you only study hospitalized patients, you mix things up and create the false association. That's called the collider bias. That's why if you remove the hospitalization, then there is the another relationship that would be produced, that is the smoking and the lung disease. That's why we never adjust colliders. Now what is the residual confounding? Even after adjustment, some confounding may remain. That is called the residual confounding. It may occur because confounder was measured poorly, confounder was categorized incorrectly, and important confounder was not measured, like it would be missed. So adjustment reduces bias. It does not guarantee perfect truth. Now the final conceptual summary of this lecture is adjustment follows causal reasoning, not statistical reflex. Design stage prevent confounding. Analytical stage control confounding. Randomization is the strongest, and the regression and the powerful propensity powerful but limited. Adjustment must follow the causal structure and not statistical reflex. And if you just adjust blindly, you do not control bias, you create it. So thank you for watching. Follow Handy Research Practical Guide to Research series, episode 6 done.